Okay, hello. As you can see, I'm recording this one from home as opposed to in the school. Just for today, I'm not in the school today, so thought I'd still record the video. Today, we are going to be continuing where we left off with yesterday. We had just finished the lesson. I made you guys do the problem set for homework. So now we're going to continue on with the next lesson. Obviously, you can find the lesson itself in your own module books, but also it is provided in our Schoology page. The first thing that is on that lesson is going to be our example 1. We're going to be continuing on with ratios today. This one reads, the morning announcement said that 2 out of every 7 6th grade students in the school have an overdue library book. Jasmine said, that would mean 24 of us have overdue books. But Grace argued, no way, that's way too high. How can we determine who is right? The main thing that this question's asking us is, what do we need to know to determine if one of them is right or the other one is right? Well, let's look at this. Let's pick out every ratio that we can get. Well, we have our first ratio right up here. 2 out of every 7 6th grade students in the school have an overdue library book. So we can write that as our ratio. 2 to 7, because we have our 2 out of every 7 6th graders has their overdue library book. So that's 2 out of 7, 2 to 7. Jasmine says that means that 24 of us have overdue books. Well, 24 out of how many? That's really the problem. So if we're trying to find out who's right, we need to know how many students are in the 6th grade to begin with. If we don't know how many students are in the 6th grade, how are we going to know if Jasmine is right or if Jasmine is wrong? Well, we can still kind of work through this to see how many people Jasmine thinks are in the 6th grade. Because we know if she's saying 24 of us, she's saying 24 out of some number. We don't know what that number is because we haven't yet been told how many kids are in the 6th grade. But we can try to find that out, because we know that these two, in order for Jasmine to be right, these two need to be equivalent ratios. So if we remember back to yesterday, how do we find equivalent ratios? Well, in order to find equivalent ratios, we have to multiply our first number and our second number by the same amount. So, if I need to multiply 2 by a number to get 24, I need to multiply 7 by that exact same number in order to get this mystery number here. So, what times 2 is going to give us that 24? Well, 2 times 12 is what's going to give us our 24. So 2 times 12 gives us our 24. Out of that, 24 of us have overdue books. So now, since we know we're multiplying our 2 by 12, we have to do the same thing with our 7. Our 7 also needs to be multiplied by 12 in order to give us our mystery number. So, 7 times 12. If we were to do 7 times 12, we would get grand total of 84. So, how can we determine who is right? It depends on how many students are in the 6th grade. If there are 84 students in the 6th grade, I'll even type this out so that we can look at it and have it written down for us. If there are 84 students in the 6th grade, then Jasmine is right. If there are not, then Grace is. But is Grace automatically right just if it's not 84? Because Grace is saying that's way too high. She thinks that there's less than 24. Which means if there's less than 24 of them having overdue books, that means that there has to be less than 84 students. So it's not just if there are not 84 students, it's if there are less than 84 students. Grace is right. And if there are more, then they're both wrong. If there are more than 84 students, then both of them are wrong. Because Jasmine said there'd only be 24 of them that have overdue books. Grace said that 24 is too large. So if there's more than 84, there's going to be more than 24 of them that have overdue books. Which means that both of them would be wrong. This right here is going to be what we're going to be working on. We're going to be given scenarios like this today, where we need to find out a missing number in order to make sure that they are equivalent. We're also going to be doing some questions that are like what we had done yesterday, where we are going to be given two ratios and we're going to be asked, hey, are these two ratios going to be equivalent to one another? Because I want to make sure that they are. If we go on to the next question, the next question actually says exactly what I was just talking about. Decide whether or not each of the following pairs of ratios is equivalent. If the ratios are not equivalent, well, find a ratio that is equivalent to the first one. If the ratios are equivalent, identify the non-zero number C that could be used to multiply each number of the first ratio by in order to get the numbers for the second ratio. What? What? What is it asking us to do? Don't get too worried about that sentence. Basically, what it's asking, if I go back to this first question, remember how we multiplied both numbers by 12 in order to find what that equivalent ratio is? This number right here, 12, what we multiplied the 2 by to get 24 and the 7 by to get 84, that is what it's asking us to find. That is C in this scenario. That number that you're multiplying it by is going to be C. So, let's get into this. Let's start off with part A. Part A is 6 to 11 and 42 to 88. So we're going to take 6, and what do we need to multiply it by to get 42? Well, if we don't know off the top of our head, remember we could just do 42 divided by 6, and that will give us our answer. 42 divided by 6 is 7, which means I need to multiply 6 times 7 to get to 42. Okay, so we know that we're multiplying that first number by 7, Well, let's see what I'm multiplying that second one by. 11 to 88. Now this one's a little bit easier for us to just see at a first glance, but if it wasn't, we could write it over here. 88 divided by 11. 88 divided by 11 is going to give us 8. So we have to multiply by 8 to get from 11 to 88. So are these two ratios equivalent? No, of course they're not. For the first number, we have to multiply by 7. The second number, we're multiplying by 8. Those are two completely different numbers. Of course they're not equivalent. So I'm going to put a check right here. No, an equivalent ratio would be, and then it gives us a blank here to write an equivalent ratio. Well, I like what we were doing with the number 7 over here. So we already know that 6 times 7 gives us 42. So we know that our first number is going to be 42. So now we need to take 11 and multiply it by 7 to find out what the actual equivalent ratio would be. So if I just go 11 times 7, we probably wouldn't even need to write this out because this is a simple one. 11 times 7 gives us 77. So remember, for this, we check like this, and then it asks us to find a ratio that's equivalent. We found this one because 6 times 7 gives us 42, and 11 times 7 gives us 77. So this ratio is equivalent to our first ratio over here. Question number 2. Well, it's not number 2, it's letter B. 0, 5 and 0, 20. This one kind of causes a bit of us to think a little bit. What do I multiply 0 by to get 0? That's a little tricky because I can't think of one number that I multiply 0 by to get 0, because any number that I multiply 0 by is going to give me 0. If I multiply 0 times 1, that gives me 0. If I multiply 0 times 2, that gives me 0. If I multiply 0 by a billion, that's still going to give me 0, because any number times 0 is going to give me 0. So I'm just going to write any down here, because to get from 0 to 0, I can multiply it by any number. It doesn't matter what number I multiply it by. So let's look at this one. We don't even really need to do this to prove that they're equivalent, because we know that no matter what number this is, it's going to be equivalent, because this number can be any number. But we still need to find out what C is. So for that, we still need to find out this. So if I need to find out what I'm multiplying 5 by to get 20, same as before, I'm going to come over here. I'm going to go 20. I'm going to divide that by 5. And that's going to give me 4. So for this, I'm multiplying 5 times 4 in order to get to 20. Now, does that work for 0? Okay, 0 times 4. 0 times 4 gets me 0. So that means, yes, this is going to be equivalent. And the value of C is going to be 4, because I multiplied both of my numbers by 4 in order to get from my first ratio to my second ratio. 0 to 5, that ratio times 4 gives me 0 to 20. And they are now equivalent ratios. So that is exercise 1. When we move on, we're going to get into exercise 2. Exercise 2, this is the last exercise we're going to be doing, because after this, I believe, is the problem set. And that is going to be what you guys are doing for homework. Exercise 2 reads, in a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. Okay? So we know that the number of walnuts to cashews is 5 to 6. Determine the number of walnuts that are in a bag if there are 54 cashews. This is asking us to use a tape diagram to support your work. Tape diagrams, that's what we were doing yesterday, so we should already be fully prepared to do this question. And then it asks us to justify your answer by showing that the new ratio you created of the number of walnuts to the number of cashews is equivalent to 5 to 6. So that, for this second part where it's telling us to justify, that means we need to write it like we wrote it up here or over here with our little triangle. So up first, we're going to be using our tape diagram. So number of walnuts and we have, let's start writing that again. Cashews. So from walnuts to cashews is 5 to 6. So walnuts, 1, 2, 3. I'm going to write these bigger because that's a little bit too small to write numbers in. 1, 2, 3, 4, 5. Cashews, it's 5 to 6. So cashews needs to have 1, 2, 3, 4, 5, and I don't know if you can hear that, it's thundering outside. 5 to 6. So my cashews, I have 1, 2, 3, 4, 5, 6. 6 boxes. Walnuts, I have 1, 2, 3, 4, 5, because we're at 5 to 6 for walnuts to cashews. It's saying we need to find out how many walnuts there are if we have 54 cashews. So this entire thing over here, we know that there are 54 cashews in there. So if I have 54 cashews in here, I have my 54, and I need to split that across 6 different boxes. So I'm going to take my 54, I'm going to split it, or I'm going to divide it by 6. And when I divide 54 by 6, what do I get? I get 9. I get 9. So that means the value of each of these boxes is going to be 9. So I'm going to go right here. I'm going to write a 9 in here. Write a 9 in there. 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 And write a 9 in there. I know some of these definitely don't look like 9s, but let me tell you, it's a 9. I have to write with a mouse. It's not too easy. So we've got all of our 9s in here. So what can I do for this? I can just label all of these boxes as 8s. I can label them as 10s. No, of course not. If these boxes are 9s, then these boxes need to be 9 as well. So now I've got 5 boxes full of 9s. So down here I have 6 boxes full of 9s. I've got 5 boxes full of 9s over here. There's 2 ways I could do this. I could either add them all together, or I could do the easier method, which is what we do for repeat addition, and I could just do 9 and multiply that by the 5 boxes that are there. And when I do 9 times 5, that gives me 45. So that means there are 45 walnuts. There are 45 walnuts. Are we done now? I've done my tape diagram, and I found out that there are 45 walnuts. Am I done? No, I'm not done. It's telling us, remember, justify your answer by showing that the new ratio you created of the number of walnuts to the number of cashews is equivalent to 5 to 6. So remember, we need to do it like this time. So we're going to take our original ratio. I'm going to go 5 to 6. And I'm going to go and I'm going to write my new ratio of my number of walnuts, 45. And I'm going to write my colon. I'm going to write 2. And my number of cashews, which were told, was 54. Now, with my arrow here, here. What do I have to multiply 5 by to get 45 and 6 by to get 54? Well, we already found it out. It's the same number we multiplied and divided over here. It's the same number that we put in these boxes. It's times 9. Really thundering out there. I don't know if you can hear it. If you can't hear it, I probably look like a crazy person just looking away every 2 seconds. So when it asks us to justify our answer by showing that the new ratio is equivalent to our old ratio, we're going to write it just like this with our little caret arrows down here. Okay? So this is, as I mentioned, this is kind of where our lesson is going to stop. With this exercise done, you guys should be completely prepared to burst onto the scene of that problem set, get it done. Shouldn't have any problems. If you do have any problems, any questions, any comments, any concerns, make sure to send me a message on Schoology. I'll be available until 4 today. I'll be at the computer side. After 4, it might take me a little bit longer to get back to you, but I'll still hopefully get back to you. With that, class is done, and I will see you all tomorrow, because tomorrow is an F day, which means that it is back to being synchronous. So I will actually see you guys again tomorrow. You all have a good day.